Listen to part of a lecture in a geology class. The professor is talking about plate tectonics.
We currently believe that the Earth's crust, the rocky part of the Earth, is composed of several large rigid plates. These plates are being created at some edges and being destroyed at others. They're also moving across the Earth. This theory is called plate tectonics. It was first put forth in 1963 by a Canadian geophysicist by the name of Tuzo Wilson. Tuzo Wilson was instrumental in advancing the theory of plate tectonics. He suggested that the Hawaiian and other volcanic island chains might have formed as a result of the movement of a plate over a motionless hotspot in the Earth's mantle. Hundreds of studies have proved that Wilson was right. However, in the early 1960s, his idea was considered so radical that his hotspot manuscript was initially rejected by all the major international scientific journals. Basically, plates are areas of the Earth's crust that move as a unit. At the present time, there are 8 large plates, as well as a similar number of smaller plates. According to the theory of plate tectonics, a plate has 3 kinds of boundaries with other plates: oceanic ridges, oceanic trenches, and transform faults. Most of the world's earthquakes and volcanoes occur at plate boundaries. This is what you'd expect because plate boundaries are where a great deal of friction and stress occur. At plate boundaries, a couple of things can happen. One is that rock is forced up from the mantle in molten form as lava at ridges. Another is that rock is melted and forced back into the mantle at trenches. This process of rock being swallowed or forced back into the Earth's mantle is called subduction. During subduction, as a plate dives into the depths, we think part of it finds its way back to the surface in the form of volcanoes. The theory of plate tectonics and the discovery of seafloor spreading have confirmed the theory of continental drift, the movement of continents. Seafloor spreading was discovered in the North Atlantic and soon afterward in all other oceans. What we found is that in the areas around oceanic ridges, the deep seafloor is formed by rising lava, which then spreads out sideways in both directions. So, does the spreading of the ocean floor mean that the surface of the Earth is increasing? No, not in the least. Seafloor spreading doesn't cause an increase in the Earth's surface. And why not? Because the lava that rises and spreads from the oceanic ridges sinks again elsewhere in subduction zones, which are nearly identical with the ocean trenches. Subduction zones are areas of frequent earthquakes and are usually associated with the rows of volcanic islands that accompany the oceanic trenches. Subduction is currently happening beneath island arcs like Japan. Subduction is also taking place on the Pacific Northwest coast of North America, beyond the end of the San Andreas Fault. This is where a subducted plate is thought to have disappeared beneath the North American plate in recent geological time, leaving the volcanoes of the Cascade Range as evidence of its past existence.